Right, okay. Students, can you can you all hear me? Students, can you hear me? Right, okay. Right. So, good evening for all of you. So today I plan to start the class a little bit earlier, students, because today we have to discuss some more reactions. So therefore, we need 3 hours for that one. So therefore, today's class will be conducted from 8 to 11. Okay. So normally our class is 9 to 11. Right. Anyhow, so let's quickly go for the reactions that we have to discuss today. So there are so many reactions to discuss today. Let's see one by one. Uh, so today we are starting from carbon atoms increasing reactions number 3, right? So we discussed 2 reactions before this one, and today we are going to learn about the third reaction. Okay, carbon atoms increasing reactions number 3. Remember, students, the third reaction that we are going to learn is uh, reactions of alkyl halides. So this reaction is related to the alkyl halides. Okay, reaction of alkyl halides with with sodium derivatives, or else we can say that sodium salts of sodium derivatives of alkyls, right? Sometimes by looking at the heading, you won't be able to understand what is exactly they have given here. But if I give you the reaction, you will understand that one very clearly. Okay. So what is the heading? What is the reaction type that they have given? So the reactions of alkyl halide with sodium derivatives of alkyls, right? So remember, students, the thing that you have to understand here is alkyl halides. Alkyl halides are reacting with sodium derivatives. Right. Okay. So students, alkyl halides reacting with sodium derivatives of alkyls. Now look at the reaction. So this reaction is very simple reaction. So what we can see here, RX. So this is an alkyl halide, right? So this alkyl halide is reacting with a sodium derivative in this way, right? Sodium derivative means you can imagine sodium plus and acetylide anion. Remember, students, CH3C triple bond CH. So these are alkynes. HC triple bond CH. These are alkynes. So these alkynes are known as terminal alkynes or else acidic alkynes. Acidic alkynes means these are containing terminal hydrogen atom. So these hydrogen atoms are acidic hydrogens. Okay? These hydrogen atoms are acidic hydrogens. So these hydrogens can react with sodium-like metals, right? We are going to separately discuss about this reaction later. But I want to remind you here how this compound is made, sodium acetylide. Right? So these are actually known as acidic co-terminal hydrogen-containing alkynes. So these are reacting with sodium-like metals. Then what will happen? So here this hydrogen atom is acidic. Sodium is alkaline metal. So acidic and alkaline metal, they are reacting and producing this kind of a salt, minus Na plus. And here hydrogen gas is liberated. So here also we can say that C minus Na plus and hydrogen gas is liberated. Okay. So you can understand that this compound, so this is actually known as sodium derivative of alkynes, right? Sodium salt of alkynes, right? We can consider this one more clearly. Sodium derivative or sodium salt of terminal alkynes, terminal or acidic hydrogen alkynes. Anyhow, so these are sodium salt made by the reaction of alkynes and sodium metal. So then what will happen? So this is not the reaction that we want to learn here. Alkyl halide is reacting with these kind of sodium derivatives of alkynes in order to increase the number of carbon atoms. Right? Now look at this one. First, we know that this is sodium plus. Just imagine this is a chlorine atom, halogen element. Then sodium and halogen element, they are connecting and producing the main product that produces are C triple bond CH, and the byproduct is sodium chloride NaC. Sodium chloride NaC. So this is the byproduct. Okay. So let's consider a few example reactions, then you will understand this one more. You will understand this one more. Example number 1. Look at this one. Let me consider small alkyl halide like CH3C. Okay. And I'm going to add here the sodium derivative of alkyne, sodium acetylide, CH, right? So normally this is the way that we are representing that sodium derivative. So don't put that one as a bond like Na hyphen C triple bond CH. Don't put like that, because this is clearly an ionic bond. That's why we separately mention sodium plus and acetylide anion, like cation and the anion. So therefore, don't put there a bond. If you put there a bond, that is wrong. You understand? So therefore, write down this one as in this way. And then sodium plus and Cl minus will eliminate as a byproduct. Then you can see that the major product is this. So students, you can see that clearly the number of carbon atom has increased, right? Even when you consider the sodium derivative. So they are also the alkyne group actually connected to CH3. And here this CH3 is connected to another 2 new carbon atoms. Now in the pair carbon chain, there are 3 carbon atoms. So that's why we categorize this one under carbon atoms increasing reactions. So you can use this reaction in conversions in order to increase the number of carbon atoms. Try to understand. So that is the importance of the reaction. Second example. Let me consider here CH3 CH2Br, ethyl bromide, sodium plus CH3, right? So what will happen? Na plus and Br minus will eliminate. So let me write down only the major product, CH3, CH2, C triple bond, C, CH3. Third example, number 3. CH3I, methyl iodide. Yes, why not? You can take iodide also. So is it always sodium derivative? Yes, it's always sodium derivative. CH3, C triple bond, C, CH. Number 4, fourth example. Let me consider chlorobenzene. Chlorobenzene is reacting with sodium acetylide. Will there be any reaction? What do you think? Actually, I taught you this one under the alcohol converting into alkyl halide, and carboxylic acids are converting into acid halide. And there also I told you that it's not possible, students. The reason is actually here in the benzene ring, the direct carbon atom, that carbon atom will connect to the chlorine atom through a partial double bond, right? So that is obtained by the resonance stability. According to the resonance stability of the carbon atom and the chlorine atom, so there will be a partial double bond. You can a double bond. A bond and it's a bargain. Anyhow, that is stable. That is stable. That is stronger than a typical single bond between carbon chlorine. So therefore, what will happen? It's very difficult to break that carbon chlorine bond. So therefore, there won't be any reaction, right? Any reaction between the salt and the chlorobenzene. So therefore, let me write down here. There is no reaction. In order to denote that, you can put a arrow. You can put a cross on the arrow, right? At the same time, you can consider this kind of a compound. Chlorine is not connected to the benzene ring directly. In this way, chlorine is not connected to the benzene ring directly, but CH2Cl, right? Intermediate carbon atom is there. And I'm going to add here Na plus CH2CH3, right? See, the advantage of using this compound is if you are allowed to use any kind of a sodium salt here, any kind of alkyne here, then you can increase the number of carbon atoms arbitrarily. It doesn't matter. So therefore, that is actually a big advantage. CH2, CH3. Number 5, right? So here chlorine is not connected to the benzene ring directly. Yeah? So therefore, you can easily remove that chlorine atom from the compound. So then you can obtain this kind of a product. Raise your hand who understood this reaction. If you have any doubts, tell me, students. Raise your hand who understood this reaction. If you have any doubts, put your doubts in the chat box. Huh? Doubts not chat box. Right, okay. Shall we go for the exercise then? So then here it is. We are going to add another reaction for the list that we learn. Okay. Soon after the class, I will upload the reaction list that we learn up to now as a list to our WhatsApp group. Okay. You can prepare that one in your notebook. What are the reactions we discussed up to now? Likewise, you can prepare them. Okay. Right. Okay. Then write down exercise. Now let's include this reaction also to the previous list that we learned, and let's do some mix questions. Students, in previous examinations, that means 2024, 2023, and even in 2022, I didn't see any kind of a flowchart pattern of questions from organic chemistry. So for your examination, we can expect some kind of a flowchart, a diagram like that, and you have to fill the boxes for the circles that we have to add regions, right, as regions. Likewise, you have to practice those kind of questions also, right? Right. Then quickly start this one with me. Number 1. methyl chloride. Can you see that we have increased the number of carbon atoms? Here we have an tertiary alcohol. Complete the first one quickly. Second one. Quickly complete this up. Let me go for the first one quickly. So students, we have to apply the reaction that we learned just now. So what is the region, what is the compound we have to add? So we have to add sodium acetylide, sodium derivative of the alkyne, and then it is producing this kind of a compound with 3 carbon atoms. And this reaction we learned last week. Can you remember? What is this reaction? Can you remember? This is the hydrolysis of alkynes, or else we can say that addition of water to the alkynes. Right? So tell me students, what are the regions we are adding in order to convert this kind of alkyne into a ketone? Can you remember? What are the regions we have to add there? Anyone? Yes, we have to put the mercuric cation as a catalyst, and then H3O plus should be added. Can you understand? Right. Then here we can see that clearly what we have added, Grignard region, CH3MgCl, and then here we can say that this is H3O plus, PCl5, and here we can say that again we have added that sodium derivative of the alkyne. So this is the part, so this is the added part newly. Okay? So therefore we can say this way, this is the compound we have added. Again, we have added mercuric cation and H3O plus. So very easy, first one. Let me go to the second one as well. Chlorobenzene, magnesium diether. So here I'm going to add aldehyde, only 1 carbon atom. So therefore, the simplest aldehyde, acetaldehyde, or else methanol is added. And here we can put H3O plus hydrolysis, and here PCl5. So the reaction that we discussed now, we have to add the sodium derivative, sodium acetylide, right? And here what we have to add, mercuric cation along with H3O plus. Very easy. Quickly complete this. So raise your hand who completed the first one and the second one perfectly without any issue. Nabil, Rihama, Mariam. Yeah. Zura. Good. Quickly do this one. Complete this. Now you had a little bit, little by little, you had to increase the speed. Last week, actually, some of the students told me that, sir, you are doing very fast. We don't have still time. We don't have time to write down the things. Plus, now you have to increase your speed. The whole විභාගට එන යන තව මාස නේද 8කින් වගේ. You all are going for the examination. Asma කෙනෙක්. Right, good. Third one. Quickly go to the third one. So in the third one, what we can do is we can go for the reverse. Mercuric cation H3O plus form the region. Renard region is added CH3 NGBr. Then H3O plus is added. Then PCl5 is added. After that, sodium derivative of the alkyne, sodium acetylide. Then again, we have added Hg2 plus, H3O plus. So they have given the final product is CH3, CH3, double bond of CH3. So you have to go for the reverse. Go to the reverse. Third one. Shall I erase second one? Shall I erase the second one, students? If you need time, tell me, okay? Right. Then let's go for the fourth one. So the fourth one is we have ethanol. PCl5 is added. Renard region CH3 MgBr. KCl. Third one and the fourth one. So let me discuss third one. So we have to go for the reverse. Now, students, we have to understand where the triple bond carbon atoms are located, right? So exactly we know that. So this is the carbonyl group. Definitely, one of the triple bond containing carbon atom should be this carbon atom, carbonyl group carbon atom. Then we have to find out the remaining carbon atom. Then you know that in addition of water molecule, that means in the hydrolysis of alkynes, what will happen is one carbon atom is taking two hydrogens and the other one is taking oxygen. So therefore, you can clearly see that this is the carbon atom who has taken oxygen. Then definitely the neighboring two carbon atoms, the left hand side one or right hand side one, should take the two hydrogen atoms in that alkyne. Then you can understand here, in this carbon atom, we have only one hydrogen. And the other remaining two are alkyl group, methyl groups. Then this is the carbon atom who has taken hydrogen atoms. Then the triple bond was located between this carbon atom and this carbon. Then the previous reactant should be CH3, CH3, CH, C triple bond, CH in this way. Now try to understand, we have added sodium acetylide. So this is the acetylide group. You can clearly see that one, right? Acetylide group. Then the alkyl halide that we had was CH3, CH, Cl, CH3, right? Remove the newly added group. Then you can clearly obtain what is the alkyl halide. So PCl5 is added means definitely the previous one should be alcohol. Secondary alcohol, OH, CH3. So H3O plus is added, and before that Grignard region is added. Then CH3H, CH3, ONGBr. Then the previous one should be definitely a ketone. What is the ketone? Oh, not ketone, aldehyde. Ne? CH3 double bond OH, right? Ethanol. Ethanol. And here we have added again mercuric and H3O plus. So we have the simplest alkyne, ethyne. That's all. So the reaction has started from ethyne. This is the third one. Right, okay. Are we done? Shall we move to the next one? Number 4. So the fourth one is PCl5 is added for the ethanol, CH3CH2Cl. And sodium derivative is added. So therefore, CH3CH2, C triple bond, CCH3. Mercuric cation in the presence of H3O plus. So therefore, so we know that actually both the carbon atoms are not containing hydrogens. Then I told you that you have to look at the neighboring carbon atoms. So this is the carbon atom who is connected to greatest number of hydrogen atoms. So therefore, hydrogen should be connected to this carbon atom, CH3, CH2, C double bond O, CH2, CH2. So this is exactly a 3-pentanol. Grignard region is added. So therefore, CH3, CH2, OMGBr, CH2, CH3, and here methyl group. Then H3O plus is added, right? Then we can see that this is converted into alcohol. PCl5 is added, CH3, CH2, Cl. And KCN is added. When KCN is added, what will happen? The chlorine will be replaced with cyanide, CN, this KCN. So this is the fourth one that we have to discuss. Number 4. Right. Now, those who completed number 3 and 4, I'm going to give you a simple conversion. Let's see how many of you can do this conversion. Okay. So, number 5 is a conversion. CH3, CH2OH. We are starting from ethanol. And students, you have to derive this kind of a tertiary nitrile or else cyanide. Okay. For this, I'm going to give you 1, 2, 3, 4, 5, 6. Not more than in 6 steps. Not more than in 6 steps. Right? Quickly. Everyone try this. Try this one. We have started from ethanol and we have to derive this cyanide compound. Not more than in 6 steps. The maximum number of steps you can use to do this conversion is 6. Give it a try. You can do it. Anyone here completed this conversion by now? Not yet. Okay. 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 Right. There are 4. Supipi, Nabil, Rihama, Mariam. Good. There are 4 students who completed this conversion. Very good. Very good. Huh? Right. For those who completed the conversion in number 5, you can try the next conversion. I'll put that one also. Number 6. Chlorobenzene. Not more than in 4 steps. Not more than in 4 steps. Right, okay. Now I'm going to do the 5th one. Let's see. So first of all here, let me put here PCl5. Then I'm going to add here the sodium derivative, sodium acetylide. Then here I'm going to add Hg2 plus, H2 plus cation. Right. Then I can add CH3 NGBr, Grignard region. Number 2 H2O plus. Then what will happen? Now the alkyl group is connecting to that central carbon atom, and it is converted into a tertiary alcohol like this. Then I can put here PCl5 again. Then I have tertiary alkyl halide. For this one, we can add KCl. 1, 2, 3, 4, 5, 6. Not more than in 6 steps. In this way. Right. So what if we add magnesium and rye for second step? Second step, magnesium and rye. Yeah, you can add magnesium and rye for the second step, but you are forming Grignard region, right? You are forming Grignard region. Then addition of acetone, CH3C double bond CH3. By addition of acetone also, we can do that one. Yes. Yeah, students, when we are doing a conversion, sometimes we may have more than one method. Okay. So raise your hand who went through that addition of acetone for the Grignard region. That means here we can add magnesium ether, then form the Grignard region, right? So for that Grignard region, we can add acetone, CH3C double bond CH3. Then I think you can produce this alcohol, right? Again, neither. And then for this one, so the same number of steps are followed. So for the second time, we are adding PCl5, shouldn't be PBr3. No, it doesn't matter, right? Adding the same region more than one time is okay. Yeah? So PP. Yes. Okay, good. So very good. Some of you have got the answer in different methods. Yeah, I have added CH3 MGBR. I have to, right? I have to add CH3 MGBR because I'm not the method following. I'm not following your method, right? So here we have already this kind of a CH3 CH2 group. So therefore, the Grignard region I should add here should be what? CH3 MGBR, right? So here H3O plus. So here we have alcohol. So here we are adding PCl5. Okay. I think you have confusion with this Br and this chlorine. No connection, na? So we have an intermediate OMGBr. After adding H2 plus, it converted into OH, right? So that is a separate. So raise your hand who completed the conversion number 6. Raise your hand who completed the conversion number 6. Okay, Nabil, Zura, Rihama, Mariam, Yalini, Yanani, Supipi. Okay, good, very good. There are 6 people. So quickly complete this one. Right, okay. Now let me do the 6th one also. So the 6th one should be like this. So for this one, what we can do? Magnesium dry ether, then can form Grignard region. CH3, C double bond O CH3. Because students, you can see that there are 2 methyl groups, carbon atom. And secondly, H2O plus. Then we have CH3, CH3, which for this I'm going to add PCl5. And for this I'm going to add Na plus, sodium derivative there. So 1, 2, 3, 4. 4 steps. So raise your hand who got the correct answer for this one. Number 6. Good, no? Very good. So that's all about the next reaction, carbon increasing reactions. If you have any doubts, students, put your doubts in the chat box. These things are not difficult, very easy. Quickly complete this one. Number 6. Right, okay. Now let's go for the next reaction type. So the next reaction type is special conversion reactions, number 4. Write down the topic. Special conversion reactions. Number 4. Special conversion reactions, number 4. Reactions of acidic or else terminal hydrogen of alkynes. Reactions of acidic or terminal hydrogens of alkynes. Right, okay. Now students, remember, normally when you consider an alkyne, so we can separate the alkynes in this way. 2 parts. So the alkynes are which are having this kind of a terminal hydrogen, and other alkynes, they are not having these kind of terminal hydrogen atoms. So these terminal hydrogens are considered as actually acidic or terminal hydrogens. So therefore, for these alkynes, they are giving a name like terminal alkynes. Terminal alkynes, right? Actually, they are not terminal alkynes. The name terminal alkynes came because of this terminal hydrogen of that alkyne. Because this terminal hydrogen is acidic, more acidic. So, can you remember we learned that in the second unit also we learned under the theories, when we consider sp hybridized carbon atom, sp2 hybridized carbon atom, and the sp3 hybridized carbon atoms, sp hybridized carbon atoms are electronegative. Okay? So when we consider the hybridization, so sp hybridized carbon atoms are more electronegative. Right? So therefore, what will happen? This carbon atom is pulling electrons from the hydrogen. So therefore, this hydrogen has to eliminate from the compound. So therefore, we consider this is actually an acidic hydrogen or else terminal hydrogen. This terminal hydrogen can do some reactions because of this acidity of it. Right? In your resource book, they have given main 4 reactions. Reaction with sodium, reaction with sodamine, reaction of silver chloride in the presence of ammonia, reaction of cuprous chloride in the presence of ammonia. These are the 4 reactions that they have given. So in conversions, we have to use these reactions as well. So let's see what are the reactions we have to learn under the special conversion reaction number 4, reactions of acidic co-terminal hydrogens of alkynes, right? So this property belong only for the alkynes which are having terminal hydrogens, okay? Now this is not belong to the alkynes like this, right? Because these alkynes are not having these kind of terminal or acidic hydrogens. So therefore we can't take them. We can't consider them. So therefore, students, remember there are only 4 reactions. We can easily remember them, okay? It's not that much of a big deal. So let me consider. We have alkyne like this, right? So this is what? Acidic terminal hydrogen. Acidic terminal hydrogen. Okay. So this acidic terminal hydrogen can show 4 types of reactions in this way. The first reaction is it's reacting with sodium metal because sodium metal is alkaline metal, right? So therefore, that alkaline metal can easily react with this acidic hydrogen. Therefore, it's producing R C triple bond C minus Na plus, and hydrogen gas is liberated. Students, I taught you this reaction. In the previous reaction, actually, we learned this one. Now again, we are learning this one as a proper reaction. So instead of sodium, we can put sodamide also, NaNH2. So when we add sodamide, what will happen? Again, sodium metal is reacting with that hydrogen, but this time the liberating gas is ammonia. Byproduct is ammonia. Why? Sodamide is made by Na plus and NH2 minus. So here we have H plus. So this H plus is taking NH2 minus and producing ammonia. So here ammonia gas is liberated. Can you understand? Right. So the next thing is very important. You have to remember this one. Silver nitrate in the presence of ammonia. Right. Sometimes we can write down this one as diamine silver. Diamine silver complex. Right. And one more thing, students. In aldehyde ketones, we are learning an identification test. In that identification test, we are learning a famous region. So that region is containing this complex. Can anyone tell me what is that region? What is that region containing diamine silver? The famous region. Yes, Tollens. Tollens region. Okay. Remember in aldehyde ketone, we had to discuss about Tollens region, failing test. Right. So the Tollens region is containing diamine silver. So if you see in the examination, Tollens region is added to this kind of acidic terminal hydrogen, yeah, there will be a reaction. So what is the product here? Remember, students, the product is actually R, C, triple bond, C. Silver atom is coming instead of one hydrogen, that is acidic hydrogen. Remember, sir, this is white color precipitate. Okay. In aldehyde ketone, we are learning that actually. In aldehyde, we are learning. So in the presence of Tollens region, aldehydes are giving what? A Siller mirror. That is very famous. Siller mirror test. Right? So we can differentiate aldehydes and ketones. We can separate aldehydes from the other compounds using the Siller mirror test, because only aldehydes are giving Siller mirror in the presence of this diamine silver complex Tollens region. So likewise, we have another reaction, students, to remember, that is ammonia cuprous chloride. Cuprous chloride in the presence of ammonia. Okay, so nothing wrong that actually if you write down this one as diamine copper plus also, it's okay, fine. But generally we can write down this one as Cu2Cl2 ammonia. So what will happen? So same thing, instead of that hydrogen atom, acidic hydrogen, copper atom will come. So this is a brown color precipitate. Brown color precipitate. So these are the 4 famous reactions of acidic or terminal hydrogens in alkynes. Remember, students. මේක ඔයගලන්ගේ resource book එකේ alkynes වල දීලා තියෙනවා. Right? Triple bonds තියෙන තැන් වල මේ හතර දීලා තියෙනවා. So these 4 reactions are very, very important. Okay? Right. So let's discuss few examples after writing this. Quickly write up. අගල දාගන්න. ටක් ගාලා දාගන්න. So now day by day we are increasing number of reactions. At the end of the whole discussion, how we can remember these things. So as I told you, this is a process, right? This is a flow. Understood? So we have conducted, I think, 2 sessions. I think today is the 3rd one, right? Am I correct? 3rd one or 4th one? 3rd one, I guess. Yeah. So therefore, students, little by little, you have to collect the things. Ek part ඔක්කොම ගන්න බෑ. Can you understand? If you can do that one, that's very good, right? I know that some of the students actually They already completed these things before I say. I know that. Really good. That's what you have to do. But this is for the majority. Majority of the students are not able to do the things as soon as possible. They need some time. For them only, I'm giving this help. So what you have to do is you have to follow me and do these reactions and practice these things, right? So we have 1 week gap, right? So I gave you some small conversions in last few weeks. Those conversions are not even we can't even compare for the examination questions, right? When you consider the past exam questions, but little by little we are going to increase. What you have to do is you have to be with this one. You have to be stick with this one. Right? You continuously do this one. Then definitely organic chemistry will be nothing. Right? The biggest challenge for you, how we can remember all the things that we learn, right? All the reactions we learn, all the 4 units we learn, together how we can remember these things. That is the big challenge. Students, not only for you, even when we are learning those things, we also have the same challenge, right? So by continuously practicing these things, continuously doing past papers, conversions, so we could be able to do these things. So likewise, practice is the important thing. Eva කටපාඩම් කරලා කරන්න පුළුවන්, you can memorize these things and do, but it's not effective, students. Remember, if you want to put these things into your permanent mind, permanent memory, you have to continuously work. You have to continuously do these things. Understood? For inorganic chemistry also, let's do something now. Some of the students are telling that they can't remember the things that they learn. So let's see, right? I'll do something for that one also. Okay. Are we done with this one? Yeah. Okay, now students, let's practice some reactions. Few example reactions first of all. And please write down these things with me quickly. Example number 1. So here, students, we can have both the products like sodium plus is connected to both sides. Okay, so both are possible, no? Because both of the hydrogen atoms are terminal acidic hydrogens. Second example. So these things are very easy. Yeah? Write with CH3 Na plus. So the third one. We are adding cuprous chloride in the presence of ammonia. What will happen? And then it is giving this kind of a compound. So this is brown color precipitate. Okay. Number 5, we can take that CH3, CH2. Sodamide, NaNH2. So nothing to worry, the same product that we obtain as we had sodium. The only difference is byproduct is a little bit changing. Byproduct is ammonia. In these cases, we obtain hydrogen. Neither hydrogen gas. And here also hydrogen gas. Right? So let me consider another example with diamine silver. silver chloride with ammonia producing diamine silver, right? And then it is giving us so this is a white color precipitate. Got it? Very easy. Very easy. Quickly write down these examples. Yes, asthma, correct. Sometimes we consider this one as active hydrogen also. Yes. Acidic terminal active hydrogen also. Correct. Very good. Yes. This one should be corrected as silver nitrate. Huh? This one should be corrected as silver nitrate. At there, what did I give you in the introduction? There also I gave you silver chloride. Nitrate. Silver nitrate amount. It's not silver chloride because silver chloride is a white color precipitate. In order to dissolve silver chloride, we have to put what? Ammonia, diluted ammonia. So quickly complete these reactions. Now we can go for the conversions again. Done. Good. Quickly. Right. Okay. Let's quickly move to the exercise. The next exercise. Number one. Second one, it's look like this. Second one, quickly. Now these things should be nothing for you. Do these things quickly. Number one, we are adding sodium, ne? Or sodamide also possible. Then students, sodium derivative of alkyne, we can add alkyl halide like CH3Cl to increase the number of carbon atoms. So here what we are going to do is we are adding mercuric cation in the presence of H3O plus. Then here what we can do is CH3 MgBr is added. And here H3O plus is added. PCl5 and KCl. First one. Very easy. Okay. How about the second one? Sodium is added. CH3Cl, alkyl halide. Here we can add mercuric cation along with H3O plus. Then benzene magnesium bromide. H3O plus. PCl5. And then we can add sodium. So Okay, students, are we done? Yeah. So let's move to the next one. Number three. Yes. Third one. In the third one, let's go to the reverse. Here we are adding the sodium derivative. Hg2 plus H3O plus CH3 MgBr. Secondly, H3O plus. PCl5. Cu2 Cl2 in the presence of ammonia. So the final product is given in this. Complete the third one quickly. So shall I erase the second one? Students, shall I erase the second one? Do you need time? Okay. So if you need more time, tell me, right? Number four. We can start from methanol. CH3 MgBr, green out region is added. Then H3O plus. PCl5. Quickly complete this one. Third one and the fourth. So in the first step in the last question, how we can find it as the reaction with sodium or sodamide. Yeah, that's why I told you. We can use both, right? We can use both sodium and sodamide. Doesn't matter, right? If they haven't given byproduct, there is no method to find out whether it is sodium or sodamide. You understand? If there is a byproduct, then we can tell that by looking at the byproduct. If the byproduct is hydrogen, definitely it should be sodium. If the byproduct is sodamide, then we can say that the compound that we have is, if the byproduct is ammonia, we can say that the compound that we use is sodium. Otherwise, we can't say what is the uh, compound that we have added, sodium or sodamide. You can choose both. So students, number three, third one is reverse, right? So definitely the previous one should be sodium derivative. This one should be hydrogen, right? Sorry. This is an alcohol, right? Green out region is added. So therefore, the previously we had acetone, a ketone, like this. And this one should be CH3Cl. Yes, alkyl halide. We have started from alkyl halide. Third one, easy. It's not difficult, easy. What about the fourth one? Fourth one is also easy. So here is friends, we can say that CH3, CH2, OMGBr. Here is the fourth one. Same thing, easy. Quickly complete these two reactions, number three and number four. Okay, students, are we done? I want to erase third one and fourth one together. Shall I? Are we done with these two? Right. Before we go for the next reaction, complete these two conversion rules. This is kind of a flow chart, right? Sometimes you might get this kind of a question also. Number 5. It's not difficult, right? Easy. But the way that they have given is a little bit different than the previous questions. So sodium is reacting with this terminal alkyne, then producing this kind of a sodium derivative. CH3Br is added, therefore CH3 group is connected there. Here we have to add the regions. Magnesium dry ether. Let me add here acetone. In this way, quickly. So here we can use CH3, C double bond OH. Green out region is added. PCl5 is added, therefore CH3, ClH. Already here we have the acetone. Remove this. Already here we have acetone. Then the summation of these two making so the final product can be written as CH3 in this way. Number 5. Quickly complete that one also. Right, okay, students, shall we move to the next one? Number 6. Right. So number 6 also like this only, a flow chart. Students, you also can prepare these kind of questions. Huh? You also can prepare these kind of questions and practice. Okay? Now you have some idea about the reactions you learn. You can prepare these kind of questions by yourself and practice. Okay. I believe that that is more effective when you're practicing organic conversions. So let me start from methyl chloride. Like before, we are going for 2 sides, 2 directions. Sodiums, magnesium with 5. So here we are adding methanol, secondly H3O plus. If we are adding sodium, PCl5 is added. Summation of these two giving a final. I think this is easy. Yeah? Magnesium dryether is added, so therefore green art region is formed, CH3MgCl. And then by adding the sodium derivative, what happened? So the main product is carbon atoms are increased, sodium plus is eliminated with chloride. Then this kind of compound is formed. And here sodium is added, so therefore, again, this kind of a scope. And here we can say CH3, CH2OH, ethanol is produced, PCl5, CH3, CH2Cl, and these two are reacting to increase the carbon atoms in this. That's all. So likewise, chain, these reactions are continuing. Done, eh? Right, good. So others also quickly complete this one. Let's move to the next reaction. Right, okay. Students, now raise your hand who understood the reactions that we discussed up to now, everything today. Raise your hand who understood the reactions that we discussed up to now, everything today. Good. And if you have any doubts, put your doubts in the chat box. Huh? Right. Now, students, let's move to the next reaction. Special conversion reaction number 5. Right. So this reaction is very, very important. Already we have discussed this reaction in theories under the Zaitsev rule. Can you remember? The poor gets poorer. That rule. So right on the topic. Special conversion reactions. Number 5. Under the special conversion reactions number 5, what we are going to learn here is reactions of alkyl halides, with alcoholic, mostly ethanolic, potassium hydroxide. Okay, reactions of alkyl halides with alcoholic potassium hydroxide. So the reaction is very simple. Now look at this one. We have an alkyl halide like this. Alkyl halide. And we are going to add ethanolic KOH. Let me write down alcoholic KOH. So when we add alcoholic KOH, what will happen? Here, halogen atom, this X means halogen atom. This halogen atom is eliminating with the nearest carbon atoms hydrogen, one of the hydrogen, as hydrogen halide. Okay, remember, when we add alcoholic KOH or else ethanolic KOH for this alkyl halide, the alkyl halide halogen atom is eliminating with the nearest carbon atoms, neighboring carbon atoms, hydrogen atom as hydrogen halide. So therefore, the remaining product will be what? Alkene. Students, we learn this one under production of alkenes. In theories, we learn this reaction under the production of alkenes. A way to produce alkene using alkyl halide. Actually, what will happen here, the next thing is, even though that potassium hydroxide is there, even after forming HX, what will happen? HX is actually acid, hydrogen halide. This is an acid. This acid can react with potassium hydroxide because potassium hydroxide is a base. So acid-base reaction. Because of that acid-base reaction, the final products are KX and H2, right? KX and H2. So we have started from alkyl halide. We have added alcoholic KOH, right? Alcoholic or else ethanolic KOH, and we have produced alkene using that reaction. Keep that in mind. So this is the reaction. Now let's consider a few example reactions. First of all, write down this reaction quick. Write this quickly. Done, eh? Right. Now look at this one. CH3, CH, Cl, CH3. We are going to add alcoholic KOH. What will happen? So chlorine, students, chlorine is eliminating with the neighboring carbon atoms. So we have two neighboring carbon atoms, both of them are similar. So this is actually symmetrical alkyl halide because both the neighbors are similar, right? Left-hand side neighbor is also CH3, right-hand side neighbor is also CH3. Then from which one we have to take hydrogen? So we can choose arbitrarily anyone, doesn't matter. Anyone, yes. So therefore, let me consider the left-hand side one. One hydrogen eliminated, then the product is CH2 double bond, CH, CH3. That's all. So if you want byproducts, what are the byproducts? HCl is eliminated, but that HCl is reacted with potassium hydroxide and produce what? KCl and water. If they ask, you should be able to write down the byproducts also. Okay? Second example. In the second example, let me consider in this way. CH3, CHBr, CH2, CH3. Under. So this is the case. Let me write down this time. This is ethanolic KOH. Ethanolic KOH. Now, students, you can see that this is a secondary alkyl halide, but this is not symmetrical alkyl halide because the neighbors are different. Now we know that anyhow, bromine atom should be eliminated from this carbon atom. For sure, it will happen. After adding alcoholic KOH, that's what happened. Bromine is eliminating. So bromine should be eliminated with one of the hydrogens from the neighboring carbon atoms. So here, neighbors are different. Left-hand side neighboring carbon atom and the right-hand side neighboring carbon atoms are completely different. Then, which carbon atom we have to choose? For that one only we learn the Zaitsev rule. Under the Zaitsev rule, I told you that the poor gets poorer, right? The poor gets more poorer. That means always when hydrogen is eliminating from a carbon atom, neighboring carbon atom, hydrogen should be eliminated from a carbon atom which is having poor number of hydrogens. When you consider this left-hand side neighboring carbon atom, there are 3. And when you consider this right-hand side carbon atom, there are 2. So therefore, hydrogen should be eliminated from the poorest hydrogen containing carbon atoms. That means this right-hand side carbon atom, right? So therefore, according to the Zaitsev rule, we have to consider that hydrogen should be eliminated from here. Then the product should be CH3, CH, double bond CH, CH3. Can you understand? Right? Students, we can consider this is the major product of the reaction. Major product and the minor product. We learned this one. Right? Now, this is the chance to revise the theories you learn again. We learn these theories. Now, again, you have a chance to revise these theories. Take the advantage. So, according to the Zaitsev rule, I told you that. So, this is actually depending on the carbocation stability. We discuss about that one. So, we know that according to the Zaitsev rule, hydrogen is eliminating from the carbon atom who is connected to poor number of hydrogens. But can't bromine eliminated with the hydrogen atom, one of the hydrogen atoms, which is connected to a greater number of hydrogen atoms containing carbon? Yes, we can consider this left-hand side carbon also. But remember, that is the minor product. There is a possibility, right? There is a possibility. So therefore, according to the, so this is actually considered as anti-Zaitsev rule. Okay. So there is no rule like that. But can you remember we learned Markovnikov rule and anti-Markovnikov rule? By adding hydrogen peroxide, we put the HBr in different way. So likewise here, Zaitsev rule and anti-Zaitsev. So what will happen is bromine is eliminating with the hydrogen atom who is connected to poor number of hydrogen atoms. Bromine is eliminated with the hydrogen atom who is connected to the carbon atom who is connected to poor number of hydrogen atoms. But we can violate that rule and we can remove one hydrogen from the carbon atom who is rich with hydrogen. That means left hand side. So that will be the minor product. CH2, double bond, CH, CH2, CH3. So this is minor product. Major product and the minor product. So as remember in the examination, they might give the conversion using the minor product as well. Now, we have to decide that one. We have to be very intelligent which product we have to use because both are possible, right? Even though this is 80%, 20% Wagi, even though we have that kind of a percentage difference, we can use this minor product also in order to do the conversion. So therefore, be careful in the conversion. You should be able to get the relevant product for that conversion. That's why I'm teaching the major product, minor product theory in these conversions also, reaction practice also. Okay. So raise your hand who understood that theory part, and if you have any doubts, tell me. Quickly raise your hand who understood that. Raise your hand who understood that. Good. Right. Major product, minor product. Sometimes we might have more than one minor product. One major product, two minor products. Altogether, there are three products. So let me consider third example. This reaction is very, very important. No? Still, most of the students are doing mistakes even after learning the theories. What about this? So students, here this is the carbon atom who is connected to chlorine. Chlorine is eliminated. So this carbon atom is containing three neighbors. So all of them are same, right? All of them are same. So therefore, we can choose any of the carbon atom and remove one hydrogen and write down CH3, C is the product. Easy, right? Number 4. We are going to add alcoholic KH for this compound. What will happen? What do you think? Yes, Supipi correct. What about the others? We discussed in the theories also, I guess. What about the others? What is the product of this reaction? Asma correct. Others? Kavisha correct. Students, there won't be any reaction. There won't be any reaction. Why? Because we know that this is the carbon atom who is connected to the halogen atom. Look at the neighboring carbon atom. When you look at the neighboring carbon atom doesn't contain at least one hydrogen. At least one hydrogen. Tell me. No. That carbon is containing three alkyl groups. All of them are alkyl groups. No, at least one hydrogen atom. So therefore, how that bromine atom is eliminating with one hydrogen from the neighboring carbon atom? So then we can go for the next one. No, it's not like that, right? So we have to go for the direct next neighbor. That's all. Understood? So therefore, try to understand since this carbon atom doesn't contain any hydrogen, that bromine cannot be eliminated from the compound. So therefore, here there won't be any reaction. Keep that in your mind. Number 4 is look like this. Number 5. Number 5 is interesting. Students, not only just one halide atom. What if we have two halide atoms like this? Number 5. We have two halide atoms like this. Then, so then what will happen is, so both the halide atoms should be eliminated from the compound. So let me consider this carbon atom connected to bromine. So that bromine should be eliminated from the neighboring carbon atom's hydrogen. Let me take this one. So this bromine atom and hydrogen, they are eliminated. And what about this carbon? Bromine, hydrogen, they are eliminated. So the interesting thing, the product is here now not alkene, it is an alkyne. So try to understand, when we have dihalide, there is a possibility to have an alkyne as a product. Okay. Dihalide will be converted into alkyne in the presence of alcoholic. Right. And remember, students, one more thing. When the two halogen atoms are connected to neighboring carbon atoms in this way, two halogens are connected in this way. This is known as what? This is known as vicinal dihalide. Vicinal dihalide. Put a note and write down note. And when the halogen atoms are connected to the same carbon atom, when the two halogens are connected to the same carbon, we consider that is geminal dihalide. These are some famous names we are using. Okay? Vicinal dihalide, which means carbon, two different carbons connected to here, two halogen atoms. Geminal dihalide, two halogen atoms are connected to the same carbon atom. Vicinal dihalide, geminal dihalide. So the fifth one that we discussed, the dihalide compound that we discussed here, was a vicinal dihalide. Number 5, this look like this. Number 6. Look at the next example. So in the 6th example, this is geminal dihalide, isn't it? Because both the halogen atoms are connected to the same carbon. Alcoholic KOH. This chlorine is eliminating with the neighboring carbon atom's hydrogen. And this chlorine is also eliminating with the neighboring carbon atom's hydrogen. Again, we have an alkyne like this. Number 6. Look at the 7th one. Look at the 7th one. So this is dibromo compound. Friends, we are going to add alcoholic KOH. Right? So I need the minor product, major product, both. Right? We have a major product as well as a minor product. What do you think? Quickly obtain the answers. Get the answers. Right. So raise your hand who got the answers for this one. Number 7. Raise your hand who got the correct answers. Right. Let's see whether your answers are correct. Yeah. So now let me erase this one. Now, students, you can see that this is not a symmetrical alkyl halide. Neither. Now, let me choose this bromine atom. Who is the neighboring carbon atom? The only neighboring carbon atom for this carbon atom is this one. So, therefore, hydrogen is eliminated from that one. And consider this bromine. So, for this bromine containing carbon has two neighbors. Left hand side this carbon atom and the right hand side this carbon. According to the Zaitsev rule, hydrogen should be eliminated from the carbon who is connected to poor number of hydrogen atoms. That means this is the carbon who is connected to 2 hydrogens and here we have 3. So therefore hydrogen should be eliminated from the carbon atom which is connected to lesser number of hydrogen. So therefore this bromine is eliminated with this. Then the product should be, the major product should be this kind of an alkyne. So let me name this one as major product. So this is the major product. Neither. Then I told you that we have a minor product as well. So here we have to be careful. Now. So let me write down the compound again. In the case of minor product, again, let's go for the bromine atoms. Here we have bromine atom. Right. So anyway, whether it is major product or minor product, whatever it is, this bromine atom has always only one option to remove one hydrogen from neighboring carbon atom. Because that carbon atom is containing only one neighboring carbon atom. Right. Next to this carbon atom, from the both side, only we have this carbon. From the other side, we don't have any carbon atoms. So therefore, this bromine has to eliminate with this hydrogen, no option. There is no option, even in the minor product. But go for the left-hand side bromine atom. So as we discussed, according to the Zaitsev rule, right, this bromine should be eliminated from the carbon atom who is connected to poor number of hydrogen atoms. That is the Zaitsev rule, and we obtain the products, relevant product in the previous one. Now, what if we unfollow the Zaitsev? What if we violate the Zaitsev? We are going to eliminate hydrogen from the carbon atom who is connected to rich number of hydrogens. So therefore, in that case, this bromine is eliminating with the hydrogen connected to greatest number of hydrogen atoms to that carbon atom. Can you understand? Therefore, we can say that the product should be like this: CH2 double bond C double bond CH2. So what is this compound? Right. Whatever the compound, doesn't matter for us. We obtain the product. This product is actually di-E. You can clearly see that carbon is having 2 double bonds. So this would be the minor product of the reaction. Major product and the minor. Number 7. Okay. So raise your hand who understood the way that we are obtaining major product and minor product for the 7th one. Do you have any doubts there? It's very easy. Yeah? It's really easy. It's not difficult, right? Yes. Then let's go for the next one. Number 8. Students, in the 8th one, you have one major product and 2 minor products. I'll give you some time. Go for the answers for this one. This is also a symmetrical alkyl halide, but actually we have more than one product. So there will be only one major product, but there are two minor products. Check that you can go for the answers. Definitely you should be able to go for the answers, right? Right, right. Done. So raise your hand. Who got the three answers? So I got three answers, one major product and two minor products. Okay, good. Okay, very good. Huh? So there are many. Huh? Continuously you do these things, will you? Definitely you will be able to do the organic conversion in examination like piece of a cake. It's not hard. Huh? Organic only difficulties actually they are in isomers. Let's discuss isomers also. Let's finish this 22 to 20, 21 to 23 marks will be there from organic chemistry. So let's take this 21, let's take 20 marks easily in the examination, okay? But before the exam, we have to practice a lot, let's say. So the next challenge you have is physical chemistry, okay? Get ready for that one. Physical chemistry lessons are started. Next month, we are starting kinetics. So starting from kinetics, equilibrium, electrochemistry, along with that one, the energetics, gas laws calculations also will be there. So that is the next challenge for you all. Okay. So big critical chemistry lessons, organic chemistry and physical chemistry, and you can change your result completely, whatever the position now you are in, right? It doesn't matter whether you are in F level low, S level low, whatever it is. Definitely you can go for A, whatever the position now you are in. Okay. So if you cover organic chemistry, physical chemistry, the big two crucial lessons, you can change your result. Mark my words. Number 8. Now, students, you can see that what should be the major product. So as we discussed before, here also bromine should be eliminated from there are two neighboring carbon atoms for the carbon atom who is connected to bromine. Left hand side is containing 3 hydrogens and this one has only 1 hydrogen. So therefore, let me remove that hydrogen. And in the same way, here also we have bromine atom. So the neighboring carbon atoms, 2 neighboring carbon atoms are there. According to the Zaitsev rule, hydrogen should be eliminated from the carbon atom who is connected to least number of hydrogens. In that manner, we can obtain the major product as this. So this is the major product. I told you that, students, there are 2 minor products. So that is the challenge you have. So let me write down the compound here again. CH3, CHBr. Just imagine both the carbon atoms are violating the SAIDSF. That means I told you that when bromine is eliminating with the hydrogen, that hydrogen should be chosen from the carbon atom who is connected to poor number of hydrogens. So let's unfollow the SAIDSF. That means let me choose this carbon and hydrogen is eliminated. And in this case also, bromine, I'm going to violate the SAIDSF rule. Actually, I have to remove hydrogen from this carbon, but I'm going to choose this one by violating the rule. Then you have a product like this. CH2 double bond CH double bond CH2. Here we have a minor product. Minor product 1. Okay. Can you understand? Minor product. And look at the second minor product. CH3, CHBr, CHBr, CH3. Now we consider both the carbon atoms are satisfying the following the SAIDSF. From that we obtain the major product. First minor product is obtained by violating the SAIDSF rule by both the carbon atoms. But here in the second minor product, I'm going to choose only one carbon atom who is following the SAIDSF rule and who is violating the SAIDSF. So let me consider this left-hand side carbon atom is actually violating the SAIDSF. Bromine should be eliminated with this hydrogen, but violating the rule, hydrogen is eliminated from here. But the next part, this bromine atom, right, then that is actually satisfying for the following SAIDSF rule. So it is eliminating hydrogen from this one or this one, this one. Then the product is CH2 double bond C double bond CH3. Minor product 2. Minor product 2. So these are the two minor products we have. Now someone of you can argue with me, so why can't we have the opposite of this one? That means this bromine atom, now it's following the SAIDSF rule, and this one is violating the SAIDSF rule. Then students, you will have a product like this. Actually, exactly the mirror image of this compound, right? So this compound and this one both are same. Can you understand? So that's why I consider we have only one major product and two minor products. We don't have three minor products, right? We have only one major product and two minor products. Can you understand? So the minor product 2 and this product I have written, both are same, exactly same. Only the direction is different. Got it? So raise your hand who got the answers for this 8th one correctly. So I got the answer for the 8th one correctly like this. One major product and two minor products. Very good. Very good. There are many. More than 10. Yes, good. Right. Right, okay. Number 9. So, okay, if you want to write down these things quickly, note down these things. And if you have any doubts, let me know about this. Done. Eh? Right. Number 9. Number 10. Right. Okay. Are we done? Okay. Then students, let's go for the practice exercise. Number 1. quickly do these things. Now you can realize that little by little steps are increasing, reactions are increasing. So therefore the conversions are becoming complicated. Nah? That's the way. Now you have to adapt for this change. Okay. Right? In the first one, we can add alcoholic KOH, right? Then we have alkyne, sodium, CH3Cl, Hg2 plus H3O plus, CH3CH2 MgCl, H3O plus, PCl5, alcoholic KOH. Second one, alcoholic KOH, mercuric H3O plus, CH3MgBr, secondly H3O plus, PCl5, sodium salt, Hg2 plus H3O plus. So likewise, you should be able to now write down the reagents correctly. Yeah. It's not that much of difficult thing. All you need is a little bit practice. Quickly complete. Shall I erase first one? Are we done with first one? Yeah. So the third one is Since shall I erase second one? Okay. So do that one quickly. Right, okay. So here, what we can do? Alcoholic KOH. Sodium, CH3Cl, Hg2 plus, H3O plus. Renard is added. Renard region is added. So therefore CH3, OMGBr. C2H5 means CH2, CH3, right? Or if you want, you can write down C2H5, doesn't matter. This should be OH. So when we add alcoholic KOH, follow the Zaitsev rule. Choose the neighboring carbon atom who is connected to less number of hydrogens. So therefore CH in this way. So in the fourth one, we can say that triple bond CH3. So here, sodium derivative. So it reacting with this in this way. OH into Cl after adding. Oh yeah, yeah. This one should be Cl. Yeah, we can consider that one also. That means when we consider sodium in excess, then you can connect sodium to both sides. Okay? Right? So if you just put sodium, only we can consider that one into one side. Quickly complete these two. Done. Right, okay. Students, these are the things actually we have to discuss today. So do you have any doubts, the things that we discussed today? Please raise your hand who understood the things, the reactions, everything that we discussed today. Quickly raise your hand. Good. Right. Okay. Then you have a small homework. What you have to do is two conversions of the day 3, isn't it? If you want, you can send the answers soon after the class. Number 1. Chlorobenzene is given. Not more than in 5 steps. Okay. Not more than in 5 steps. Number 2. So this is also not more than in 5 steps. So very easy two conversions. So D, do these two conversions as a homework. Okay. Right. Okay. Then students, these are the things that we have to discuss today. So do you have any doubts, any one of you? Please raise your hand if you have any doubts, anything. You can put your doubts in the chat box. Okay, well then I think you don't have any doubts. Right. Then let's meet on the next session. Friday you have a paper class. Then let's meet in the next session. Until then, bye bye. Have fun. Good night. God bless you, all of you.